This is IAT355 Lecture 8, Interaction. So today what we're going to be talking about is first off an overview of what we're talking about with respect to interaction. Interaction as it's applied to visualization systems and visual analytics systems. And next we're going to be talking briefly about selection and tooltips and things that are fairly closely related to selection in the domain of interaction. And third, in this lecture, we're going to be talking about zooming, both geometric zooming and semantic zooming. So let's get started. So first, as an overview, what I'm going to do is talk briefly about why it is we care about interaction. I'm sure we all do care about interaction, but I wanted to essentially cover it to get a good sense of the reasoning that we're going to be applying throughout the term. So one of the primary issues that we need to deal with when we're thinking about doing visualizations is that we often have a problem with scale. That is to say, there's a lot of data, and we need to be able to manage that data in some way. And being that we're always using interactive computing systems, we would like to be able to manage that data in a manner where we can rapidly make our views known to the tool and enable the tool to show us the stuff that we need to show it. And what we're showing here in our three pieces of visualization clip art is three complex data sets, complex visualizations. The one on the bottom right is a map of New York City area and lots of locations represented by little dots, and some of them sort of the tiny little images representing, photographs of those areas. On the bottom left, we have a visualization of something somewhat different. This is a visualization of check-ins and updates to a software repository measured quarter by quarter. There are a number of things being visualized here. Additions, deletions, commits, and the number of commits, per quarter is represented by this curvy line graph. The additions and deletions are represented by the bar graph, and I think the total lines of code is slowly increasing in this software repository, and that's represented by, in essence, the background gray thing. Now, clearly, we're in the background gray increasing graph that we're talking about 300,000 lines of code here on the upper right. So there's a lot of data, and you'd probably, if you're interested in this software repository, wanting to look at the history of check-ins, you wanted to be able to get a good sense of what's going on there, and to be able to see in detail some of the time what's happening with some particular check-in. Maybe you're looking for an error, maybe you're just trying to get an understanding because you want to participate in that software project, either at the job or as an open source movement type of activity. So the other thing that is important with dealing with visualization is that you often have, as a means of dealing with lots of data, you often have multiple views, and we've seen little elements of that already, and you've probably seen it a lot in your own explorations of the visual world, where some part of the visualization or some part of the data set is represented, say in this case on a map of the USA on the left, center left, and some other part related to it is represented by a scatter plot or bar chart or something like that, and those views are somehow connected to each other. It's fine if they're connected to each other and the scales say these are the same dimension, but it's even more intuitive and understandable if the connection is live and interactive. And so that's why we're going to be talking about that stuff as we move forward. So when is static not enough? Well, one of the primary situations where static is not enough is when there's just too much data, as I've already mentioned. Just simply the quantity of data is too large, and either the visualization system is approximating it in some way, or sampling it in some way, or in other ways dealing with the bulk by showing you not everything. Another thing that's very important, probably more important actually, is that there are too many data dimensions. That is to say, there's dozens or hundreds of variables in either a table or a set of tables that you want to look at and understand what's going on in the data, and you need to be able to grapple with a subset that you can visually understand. And visually understanding 20 variables is very difficult unless you have some kind of organizational idea. Another method or means of dealing with grappling with static is that when you're trying to tell a story, it's often the case that you want to show image after image. And that's kind of in the presentation case that we mentioned earlier on in the term, where you want to present some findings that you've discovered, and you want to step the viewer, the reader, through the findings that you've made. On the other side of the sort of consumption side of the house is exploration and learning. And both of these things are about using interaction for the purposes of trying to understand what's going on in the data. And much of my discussion throughout the term has been couched in terms of gaining an understanding of data, and clearly interaction will help you with that, or enable it, in fact. And both exploration and learning, it's going to work better when we are actively able to manipulate and engage with the data and with alternative, say, hypotheses, alternative views, alternative theories, whatever it is. If you can engage with it interactively, we've learned to be really good at gaining a better understanding of the data that we've got. Okay, so interaction reveals different subsets of data. We'll talk about that briefly. Highlights relations between data subsets and views. Clearly, that's very important. Explicitly enables the query process. That's one of the things that, in any website that has a data backing it, there's some kind of query system going on. It's either explicit or implicit, either through search, and if there's a visualization method attached, then there's probably some form of visual query. And so interaction, of course, is what enables that. And also, interaction facilitates investigation and discovery, as I've already mentioned. So in interaction and analysis, the two main components of InfoVis, kind of the things we've been emphasizing so far, are the visual design and the data analysis on the bottom right. Visual design in green, data analysis in blue, and in the green plus blue area here we have what you could call static visualizations, drawing static pictures, the things you would print, of course. So that's the representation and the interaction that tends to get focused on. The representation we're going to be talking a lot about throughout the term. And representation tends to get the attention in InfoVis circles mainly because it's about viz. And so visual representation is very important. But interaction is where the action is. And that's represented by this third orange circle here, where broadly the field of interaction design, or the design of interactive systems, encompasses user interface design as it interacts or overlaps with visual design, exploratory data analysis as it overlaps with data analysis, and interactive viz in the sweet spot here, where the overlap of those three domains of work lies. And so that's what we're going to be talking about as we move forward. So it's very challenging, just speaking of, if you're thinking about continuing to do work in this area, doing research, it's very challenging to come up with innovative new visual representations, but there's still some interesting work to do with how the user interacts with a view or with views. It's what distinguishes InfoVis from static visual representations on paper. And the other thing, particularly recently, it's become much more salient and people are paying a lot more attention, researchers are paying more attention to it, is analysis as a process that's often interactive with branches and sidebars. And managing that, or at least providing the machinery to manage that, is something that I think is still not well served in many tools, and it's something that new tools will continue to improve and develop further. So we've spoken at length about interaction, and we kind of all already know what it is. But let me put some definitions in front of you. The thing that I'm talking about when I'm saying interaction is response times of 1/10 of a second or less, or 100 milliseconds or less. So why 100 milliseconds? Well, that is about human perception. People are able to, if the update rate is less than 10 frames per second, which you hopefully don't see much of these days, then you see a sequence of still pictures, perhaps rapidly presented, but not fusing together as a smooth animation, or even a bad animation. And so that's what I mean by visual animation and visual continuity. The machinery has to be presenting new images according to the current situation, whatever it is, at least 10 times per second or more rapidly. Similarly, interaction has to take place with that response time of 1/10 of a second or less, or 100 milliseconds or less. If the machinery responds slower than a tenth of a second, say half a second, or slower than that, 1 second, then what happens is it's kind of a not interactive interaction. What happens when your machine is so slow that it's responding slowly is that you move your cursor around, your mouse cursor around, and then you wait for the machine to respond to you. And when you've seen the outcome of your move, then you plan another little move in your head, move and wait. So that kind of strategy is something that you naturally adopt, either that or you naturally adopt the strategy of shouting at the computer. We've all done that. That's been tested for in the 1970s by Sheridan and Farrell. That's a kind of a discovery that's, is kind of the benchmark. You got to go faster than 100 milliseconds response time. Say, 33 milliseconds or a 30th of a second is the kind of thing that you really want to have. So most systems can deliver that, and most interactions that you are able to engage with, particularly in professional software, split the interactive task into different categories. The stuff that's supposed to happen really fast, like scrolling on a scroll bar and so on and so forth. The stuff that's intended to be slow, things that I've labeled as 1 second system response or a conversational break, those types of things where you're issuing a query to a database and waiting for the response, and it's a small query somehow without not much complexity. And this longer thing here, 10 seconds, it's a kind of the amount of time it takes to think about something. And it's also the kind of time that you can accept for a computer to think about something. Of course, it's not thinking, it's doing processing. But if your computer is taking longer than a tenth of a second, then your expectations of the computer's responsiveness, adjust to the slowness of the database, of the data set that you're interacting with, and you plan accordingly. So interaction, what I'm talking about is the first one, the tenth of a second or better. All right. So it turns out that even a simple interaction can be quite powerful. So this thing here is called dancing histograms. I'll show you the static example, and then I'll go to the website in a sec. Here, this is showing fruit sales from 1992 to 97. Just some random example. Dates: clementines, bananas, apples. Clementines, some kind of orange. And if I were to ask you, what was the sales trend over the years for clementines, you'd find it a little bit hard to answer. And the reason why is because this is an example of measuring a vertical length, on a moving scale, right? The baseline for clementines moves around because each of these fruits is stacked on top of the other ones in the same order. Apples, bananas, clementines, dates. You can see what the sum is, but if you wanted to pick off an individual element, you prefer to be able to do that somehow rather independently. Right now, you have to add them in your head. Here now, I've rebased it onto bananas, and I can see that bananas had a little dip between 92 and 94, and then increased slightly through to 97. It's hard to get that. In fact, if you just kind of looked very quickly, you might think that bananas increased and then decreased with a peak at 95, and that's not what happened. That's in fact what happened with apples. Okay, so now let's take a look at the website. Hold on. Okay, so here's dancing histograms. This is at the website blocks.org, Mike Bostock's site, and this is an example by Mark Hansen, as you can see. And so here's the data set of fruit and veg over the course of 6 years. And when I hover the mouse above each individual bar, I get a little tooltip saying what it is, when it is, and the value, which is nice. And also, of course, I can click on this stuff, and I see now what happens is that the entire suite of bars re-origins according to the bottom level of bananas, the lowest extent. And that now enables us to read the bananas thing. There's the bananas values. They don't change much, 21 to 23, to 21 to 24, etc. Clementines, the question we started with, there's a decline in clementine and then a small increase near the end. And finally, dates. Let's take a look at that. It's a funky color for dates. Pretty, similar values all the way along, except for this one value where it's 3 instead of 7. This thing also does something very nice. It animates smoothly, right? And it moves the legend up and down. So this thing can be valuable, first off, to pick off, what's the trend, what happened year over year with respect to any of these 4 items. And it can also, when you rebase, let's say at clementines, you also get to be able to read, by reading downwards, down from the top baseline, what the value for bananas is. So clementines above, bananas down below. So that's a very simple little visualization. And, it's an indicator of, the power of interaction. And what the interaction there is doing for you is it's freeing you from the burden of having to do mental arithmetic in order to examine something over time in this instance. And it's also, the representation of stacked bar charts is giving you opportunity for you to be able to sort of read what is going on with the total of fruit sales. Let's say this is a fruit stand or something, just a little data set for the purposes of illustrating the point about interactivity. Okay, so one of the ways of thinking about interaction is, how do we structure it? And Dr. Munzner spends, chapter 11 and 12 speaking of these issues. But the notion of doing interaction has been around a long time in the domain of visualization. And one of the sort of leaders in visualization, Ben Shneiderman, has what's called Shneiderman's mantra. And the way it goes is this: overview first, zoom and filter, then details on demand. And, this thing is repeated over and over here and there. And if you type that into Google, you'll see it labeled as Shneiderman's mantra. And what he's envisioning when he says this is that there's a particular style of doing visualization. You start with the big picture and you focus. Focus, focus, focus. There's nothing wrong with that big picture, but not all visualizations are necessarily built that way. You'll recall that Tableau says read in all the data and then you pick off and start to visualize the elements that you want to visualize. But in any case, this is one of the standing ways of doing it. And many visualizations are like this. Think of Google Earth or Google Maps. Start with the big, start with Canada, start with the world, and zoom down to, where can I get a good pizza, that kind of thing. That is a filtering, zooming suite of activities, starting from the big picture and going down to drill down to the thing that you're interested in. So that's a classic way of doing visualization. And it encapsulates kind of the many interactive elements that you'd need. There are other interaction organizations. This one by Dix&Ellis is another standard one. And these two folks published a paper in 1998 proposing overview as interactive kind of categories: overview and context, things like doing zooming and fisheye lenses. We'll talk about that somewhat later on in the term. Highlighting and focus, that is to say, doing something interactive in which your attention is focused and that attention is represented in the scene. Accessing extra info, digging up more. The tooltip is an example of that. Drilling down, add hyperlinks, that is to say, reach out from the data set. Same representation, changing parameters. Organizing the visual representation in a different way with different parameterizations. That could be, it depends on the visualization, but that could be about changing the color map or things like that. And linking representations. And the thing that's important about that last is when there's more than one visualization, together in your visualization system, you'd like to be able to see interaction on one piece connect to interaction on another. And we'll talk about that later on. Okay, and finally, in Munzner's book, Chapter 11 focuses, you need to subdivide the universe in various ways. Those previous things are kind of very broad and general, but, a lot of work has happened since Schneiderman's formulation. And so it's been 22 years since the Dix&Ellis formulation. So, Dr. Munzner's book was published in 2014, and she breaks things up into two subparts with respect to interaction. The first is this thing that you see here, and it's at the start of chapter 11, manipulations, interactions that you would do with a single view. And we're not going to be really talking much about changing over time, but we will talk, animating the change of the data set over time. And we saw that the other day with windy.com, for example, is a change over time type of thing. But one of the things that you can do interactively, of course, is identify one or more or a bunch of things in which you're interested in those data items, and the purposes, generally speaking, is you want to do something more with them typically. Next is a category of 3 things, navigate. We'll talk about that in the 3rd segment of today's lecture chunk. And then another category of activities called attribute reduction. Each of these things is something that you could do where you just essentially have a single view of the data, and then what you want to do is to control what you're viewing in that single view. So that's the way that Munzner breaks it up. Chapter 11 is about single view. Chapter 12 is about multiple views, multiple visualizations working together somehow. Okay, so that's it for the overview. And the next thing we'll talk about is selection.